Hello, everyone. In this video, we will discuss derivatives of inverse trigonometric functions. Derivatives of inverse trigonometric functions. These are the differentiation rules for inverse trigonometric functions. Which are valid whenever x is in the domain of the function. Let us review some inverse trigonometric identities. Reciprocal arguments. Negative arguments. Derivation of the derivative of the inverse sine function. Let y equals the inverse sine of x, which means that the sine of y is equal to x. Take the derivative with respect to x of each side of the equation. The derivative of the sine of y is cosine of y. However, because y is a function of x and we need its derivative with respect to x, multiply the result by the derivative of y with respect to x. This differentiation process is called the chain rule, and it is applied in differentiating composite functions. Use a Pythagorean identity to express cosine of y in terms of sine of y. Afterwards, express the equation in terms of x. Substitute x equals the sine of y. Divide both sides of the equation by the square root of quantity 1 minus x squared. Therefore, the derivative with respect to x of the inverse sine of x is equal to 1 all over the square root of quantity 1 minus x squared. Derivation of the derivative of the inverse tangent function. Let y equals the inverse tangent of x, which means that the tangent of y is equal to x. Take the derivative with respect to x of each side of the equation. Apply the chain rule as in the previous derivation. Use a Pythagorean identity to express secant of y in terms of tangent of y. Afterwards, express the equation in terms of x. Substitute x equals the tangent of y. Divide both sides of the equation by quantity 1 plus x squared. Therefore, the derivative with respect to x of the inverse tangent of x is equal to 1 all over quantity 1 plus x squared. Derivation of the derivative of the inverse cosecant function. Let y equals the inverse cosecant of x, which means that the cosecant of y is equal to x. Take the derivative with respect to x of each side of the equation. Apply the chain rule as in the previous derivations. Use a Pythagorean identity to express cotangent of y in terms of cosecant of y. Afterwards, express the equation in terms of x. Substitute x equals the sine of y. Divide both sides of the equation by the negative of the absolute value of x times the square root of quantity x squared minus 1. Therefore, the derivative with respect to x of the inverse cosecant of x is equal to the negative of 1 all over the product of the absolute value of x and the square root of quantity x squared minus 1. Examples. Find the derivative. Number 1. Y equals the inverse sine of negative x minus the inverse cosine of negative x. Solution. Rewrite y so that it fits into an inverse trigonometric function rule. Use negative argument identities. Y becomes the negative of inverse sine of x minus pi plus the inverse cosine of x. Take the derivative of y with respect to x. Apply the sum or difference and constant multiple rules. Differentiate using constant and inverse trigonometric function rules. And simplify the derivative. Therefore, the derivative of y with respect to x equals the negative of 2 all over the square root of quantity 1 minus x squared. Number 2. F of x equals the inverse secant of x times the inverse cosecant of x. Solution. F prime of x is the derivative of f with respect to x. Apply the product rule. Differentiate using inverse trigonometric function rules. Simplify the derivative. Combine these expressions. The expressions have the same denominators, hence this process is straightforward by combining the numerators. Consequently, f prime of x equals the inverse cosecant of x minus the inverse secant of x all over the absolute value of x times the square root of x squared minus 1. Number 3. Y equals 1 all over the inverse tangent of x. Solution. dy dx is the derivative of y with respect to x. Apply the quotient rule. Differentiate using the constant and inverse trigonometric function rules. Simplify the derivative by using a property of fractions. Therefore, the derivative of y with respect to x equals the negative of 1 all over the square of inverse tangent of x times the quantity 1 plus x squared. Number 4. F of x equals the inverse cotangent of x minus 1 over the quantity 1 plus x squared. Solution. f prime of x is the derivative of f with respect to x. Apply the quotient rule. And then, differentiate using basic differentiation and inverse trigonometric function rules. Simplify the derivative. Multiply the factors in the numerator. And combine the rational expressions using the LCD method. Rewrite the numerator by factoring out -1. Because of this, the numerator becomes the square of a binomial. Hence, f prime of x equals the negative of the square of the quotient of quantity x minus 1 and quantity x squared plus 1. Number 5. H of w equals w squared times the inverse cosine of w plus the inverse sine of w. Solution. H prime of w is the derivative of h with respect to w. Apply the sum and product rules. Differentiate using basic differentiation and inverse trigonometric function rules. Simplify the derivative by combining these expressions. And using a property of exponents. Thus, h prime of w equals 2w times the inverse cosine of w plus the square root of quantity 1 minus w square. Number 6. Prove that the derivative with respect to x of the inverse cosecant of x is equal to the derivative with respect to x of the inverse sine of 1 over x. Solution. Differentiate using an inverse trigonometric function rule. However, instead of a variable, put the argument of inverse sine in place. Because the argument of inverse sine is a function itself rather than just a variable, multiply the derivative of inverse sine, the outer function, by the derivative of the argument 1 over x, the inner function. This differentiation rule is called the chain rule, and it is used when differentiating a composite function. Differentiate the argument or the inner function. Simplify the derivative. Combine the rational expressions in the denominator. Then, apply properties of fractions. The square root of the square of a variable is equal to the absolute value of that variable. Meanwhile, the square of a variable is also equal to the square of the absolute value of that variable. Simplify further by dividing out a common factor. Therefore, the derivative of the inverse sine of 1 over x is equal to the negative of 1 all over the absolute value of x multiplied by the square root of quantity x squared minus 1, which is also the same as the derivative of the inverse cosecant of x. Thank you for watching. Please like this video and subscribe to Professor Reginald's channel to get the latest updates.